part is just vector addition, but we're going to use an algebraic method. So in these, so I'll start us just by giving, for example, I'll say vector A, let vector A be or equal 4, 5. And vector B equals 2, -2. So if we wanted to, say, add them together, vector A plus vector B, how do we do that? Well, first looks like, 4, 5 plus 2, -2. That still doesn't seem helpful. It says algebraic method, but that isn't any kind of algebra you've seen before. So what we've figured out, and I know we talked about it in class, and we even demonstrated using visual, like actual vectors in a field. But what it turns out is that this vector addition is as simple as adding the x's together, so 4 plus 2, comma, and then 5 plus -2. Okay, and then if you simplify that, your vector a plus b is 6, 3. And if I wanted to do another example here, we'll do this one in red. But if we did another example, let's say 2a, so 2 times vector a plus 3 times vector b. So what this does, it doesn't change the direction of the vector, but the 2 in front, the 3 in front, it just stretches each of your points. So in this case, you take 2 times vector a, so 4, 5, plus 3 times the vector b. And as you simplify that, so that really becomes, you just distribute the 2 to say 8, 10. Right? You just double both your first points, and plus 6, -6. And then again, when you do these vector additions, you say x1 plus x2, and then y1 plus y2. And what you end with is 14, 4. So vector addition, in terms of algebra or algebraic method, it's pretty straightforward once you understand that all you have to do, and I can have more than 2 vectors, you just take all the x components and add them. And then when you add them, that number becomes the final vector's component form x. And then you take the y components, add them all up, same thing. If we wanted to do vectors in 3D, which I don't think we're ready for, but really it's no different. Vector additions, you would just take all the z coordinates of your vectors and add them up and get a component for the z for your final. So each of the following, given w, y, and z, down here just says perform the following. So if we want to do these, we can. W and y is just, so the x components, w and y is 2. W plus y, and then the y terms, 1 and 5. So that equals -2, 6. And we're done. We'd box that in. Z minus 2y. So I'm going to write this out in the component form. So Z is just -3, 0. Then we're going to subtract 2y. So I'm going to show that. So 2 times y is 2 times the first component, so 4. And 2 times that is 10. Okay. Now we have our components. What we're going to do is look and say -3 minus 4, -7, and 0 minus 10, -10. And that is how you do those. The last topic of section 1 here in unit 4 is kind of going back to the unit circle in a sense. So the unit circle is that idea that you're a circle whose radius is 1. And when we look at a standard unit vector, it's the same idea, but instead of a unit circle radius 1, we have a vector I and a vector j, which we call standard unit vectors. Those vectors are 1, 0 and 0, 1. And this idea that being able to multiply vectors and things, they're kind of all coming together for this standard unit vector topic. So what I'm going to show you here is in the rest of the notes for this section, we start with this vector I. So vector I itself, in component form, because we have our triangle brackets, says we start at 0, 0, and you go over to 1, 0. J is kind of the opposite. It starts at 0, 0, and goes to 0, 1. So any vector that we've been working with in component form can be written also in terms of the standard unit vector. So basically what we're doing is we're learning a different way to write a vector other than the triangle bracket form x, y. So what happens is we start with vector v, and in component form it says triangle bracket and then the point c, d. But in doing that, what we're doing is we're kind of going backwards. We're going to split this component form into the endpoint c, 0 and 0, d, because c, think about it, c is the x component. So if we wanted to add these two vectors together, c plus 0 gives us c, and 0 plus d gives us d. So we've kind of worked our way backwards to create a vector that is, rather than one component, it's two of them added. Once we have vector v from c, d into two separate vectors, c0 and 0d, we're going to factor out c and in the first vector, so c times 1, 0 and d times 0, 1. But so basically we're just proving where it comes from, because then 1, 0 is vector I and 0, 1 is vector j. So at this point we can now call vector 1, 0, we can just call it vector I, and same thing with the d times 0, 1, we can just call that d times vector j. So this whole thing boils down to what we call a linear combination for vectors. And this whole thing with how we got here, this form, a lot of times it's called AI plus B times J, and that is a lot of times what we call our linear combination form or standard unit form. So essentially it's no different than what we were doing by having a component form vector. We're just we're going to start seeing them written differently. So if we look at the examples here quickly, so DE has point D at this coordinate and point E at this coordinate. It just says write vector DE as a linear combination. So rather than say write it as component form, it says write it as a linear combination. So step one is finding the component form of DE. So that's getting the vector to be back into that 0, 0 start position. So to do that, that is, thin that out, 4 minus negative 3, so x2 minus x1, and 5 minus 2. So our vector in component form says step 1 is 7 comma 3. And then step 2, rewrite the vector as a linear combination. So if you look at what we did from start to finish, if we had vector that was c comma d, so in our case 7 comma 3, if we wanted to go from vector component form to vector linear combination form, we have c and d, and we write it as ci plus dj. So this one here just asks us to write it, excuse me, as just the 7i plus 3j. Just like that. So the hard part would be getting it to component form if it's not already there. If it's in component form, to write it in the linear combination, it's very simple. You just take the numbers and you throw I and j in front of it. Here, practice B, or yeah, part B in example 5, same thing, just different points. So if we look at that, DE, vector DE is equal to 2 minus negative 6, so x2 minus x1, and then y2 minus y1, so 5 minus 0. So step 1, component form is 8 comma 5. And then step 2, write this form, component form, in a linear combination. So you literally just write it as, so DE, vector DE is equal to 8i plus 5j. That's it. So that's the last thing. If you start looking at some of this, we've got practice problems, turning them into component form and doing some addition, and then breaking it up. And there it is. So, excuse me, that is all of lesson 4-1. It's the foundation for all the rest of Unit 4. We will build on this quite a bit, so make sure you get a good grasp, good understanding of this section.